We'll wait just another minute. Sure. Looks like some people are still trying to close up some stuff. Wait for that one gentleman to come back. All right. Let's All right, let's go ahead and get started. Are we good to start the stream? Yeah. Is it starting now? Okay. So, okay. Why? Oh no, this is gonna be pop-ups, isn't it? That's not what I want. No, crap. Okay, there we go. Great. All right, so hello everyone. Welcome to the next session on project setup. We're going to set up the project that hopefully you will use for the remainder of the bootcamp. And if we all set up the project in the same way, it can make future troubleshooting easier. So I ask that you follow along closely. This will be a combination presentation and hands-on. Okay, so have your notebook ready. Be ready to follow along. If you need help, flail around a lot so we can send someone to help you, okay? Good? All right. So we have a lot to cover, and we only got 30 minutes. Are you ready? We're going to go over what is a common folder structure for Python projects. We're going to go over how to write a proper README. We're going to make sure we set up a Git Ignore file properly and explain what that is. We'll go over licensing and why it's important, and every project should have a license. We'll go over setting up your project configuration file, and then we'll talk about virtual environments, dependency management, all sorts of fun stuff. It's a lot, but ideally you only have to set it up once per project. And hopefully you can set up a nice little template for yourself that you can just copy over and over again, and you don't have to think about it too much. But the goal for today is to help you understand what is required to put together a nicely organized project and understand what it all means, at least to some degree. Sound good? All right. So, as usual, again, this is just how we do things, okay? This is not like the tried and perfect way of like, this is how you should do Python projects. This is just how I think is best to do it. There are differing opinions, okay? And I am not a complete expert. I have not written a book on Python. This is just how I do it for all the projects that I work on, including all the projects that I demonstrate here with CodeSeoul. And no one's complained to me about it yet, so I think it's pretty good. So, starting with folder structure. First off, every project should have its own folder, okay? Don't have a bunch of different projects code in the same folder, okay? Each project should have its own folder. The exception is mono repos, but that's a big crazy thing that we're not going to cover today, all right? So ideally, you have all of your kind of project level configuration and all of your project information files in that top level folder for your project, okay? So this includes your README, your license, your project configuration file. We'll talk more about these things in a minute, okay? And then you put your code in a directory called src, okay? src is short for source, okay? It's very, very common in Unix land, all right? So if you see src, you just say source. Like at this point, I don't even really see the letters src. I just see the word source when I look at it. It's very, very common, okay? And then you put your Python packages inside that source folder, okay? So ideally, you would have source / whatever the name of your project is as a package / all your files. All right, does that make sense so far? Cool. And then ideally, you should have tests, and tests should also be in a top level folder. Okay. Now, this is a good way to do things for a couple of reasons. Crap. 1 second. Let me. No, why does it keep going on that window? Okay. Sorry, guys. Yeah, if you can come here and grab them at some point. I'll just, thank you. So nice having help. Right, so the, in your source directory, it is possible to have multiple modules, multiple top level modules, but you usually only want those if you're doing a mono repo, okay? Which again is a special case that we're not covering today. So usually it should be source, the top level module name for your Python project, and then all the other modules and all the other source files, okay? So now let's go ahead and go into those configuration files that I mentioned. Okay, so first off is the readme.md, okay? This is the first thing people see when they look at your project. If they look at your project on GitHub, GitHub automatically shows the contents of the README first, okay? It's basically the introduction to the project, okay? The screenshot you see up here, that is the README for Fast API. It looks pretty, right? And that's all just text, right? Except for the Fast API logo, but you reference that with text, okay? In this README, you want to describe your project, okay? You want to tell users how to set up your project and how to run it, okay? It's also a good idea to mention any limitations. Does your project not work on certain areas? Does it not work on certain types of computers? Does it not work with certain versions of Python, okay? Are there any rules in terms of like how it should be used, right? Maybe there's some security concerns that you should make people aware of. Also, it can be useful for marketing, okay? So like Fast API is a big giant project, so it has a really nice big logo, and this is pretty much designed, like that's a form of marketing, if you will. And then the README is written in Markdown, okay? That's what the MD is. MD is short for Markdown. Markdown is a way to format text in a really fancy, easy way by very simple typing, okay? So who in the last session actually made a GitHub repository? Can I see a show of hands? Okay, great. Well over half, almost maybe 3/4 even. Go ahead and open that up because we're going to do this now, okay? So, crap, I didn't prepare for this as much as I probably should have. The story of my life. Okay, so what I'm going to do is I'm going to skip all the GitHub repository stuff, and we're going to not do that. We're going to instead do this. I'm sorry, guys. Give me just a second. Oh, come on. Why is it now that you are being slow? You're plugged in. Okay. No, that's not what we want. I'm sorry, guys. Almost there. What the hell? No, 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 no. Sorry. Okay, anyway, I will try to multitask this. Oh, oops. Let's not have that there. Okay, great. So Markdown, which I'll demonstrate in just a second, it's very simple to make very nice looking things with minimal effort. Okay, there we go. All right, so I have an empty project here. There we go, spectacular. And I'm gonna make a README. Now I'm using VS Code. If you guys are not using VS Code, that's fine, but have some kind of text editor. Okay, so I'm gonna do, bro, really, why do you do this to me? There we go. So I'm gonna make my readme.md file. Okay, now if you set up a GitHub repository, right, on your local machine, you should already have a README file. Okay, but in this case, what is happening? Okay. So I have a blank README, right? And if you do a single hash mark, You can see like, this is the type, or this is, I can say, you know, project setup. Oh my God. Project setup project, right? And then I can say, this is normal text. I can say like bullet points, okay? Everyone see this okay? Whoa, too much. Okay, something like this. Good, good, good. Now, no. Also, if you're not very familiar with VS Code, that white dot up here means that I have not saved the file, okay? So Control S or Command S to save the file, and that should save you time and effort. Now, if I do a preview here, that looks a lot prettier than what I typed, right? That's Markdown, okay? So I'm not going to cover, oh, sorry, one more thing I should show you. This is a code snippet, so I can say echo like hello world, something like this, and it formats that as code, okay? This is just some of the basic stuff, okay? You can add more hash marks to do different levels of headings and all this kind of stuff, but we're not gonna do a full Markdown tutorial because we do not have the time for that. But in any case, this is how you can make your README file look nice, okay? So set this up for your project. Don't do the whole setup now, okay? But make sure you understand this is how to set up a README for your project. This is the first thing people see. Again, going back to our presentation here, you want to include like a description of your project, how to run it, all that sort of good stuff. Questions? So.
It's sharing the.
Oh, got it. Sorry. I'll fix it. Yep, I'll fix it. Thank you. Sorry for the trouble. There we go. Now it should tear the whole screen, not just the window. Better? If I pull this up. Better, better, better. Spectacular. Okay. Sorry, I messed up the stream. Okay. So moving on. Next up is a Git Ignore file. Okay. Now, usually when you create a new repository on GitHub, you can just choose what language you're using for your project, and GitHub will just generate a Git Ignore for you. But Git Ignore basically just shows is where you list what files Git should not worry about. Okay. So this includes stuff like maybe system files. Like, for example, if you're on Mac, it tends to create that like .ds_thumb folder or whatever. Like, you want to ignore that, right? That's not part of your code. That's not part of your project. That doesn't belong in the repository. Or if there's secret information, let's say you store some of your like environment variable passwords in some file, right? You don't want that in source code, okay? So you use your Git Ignore to basically keep stuff from getting to GitHub. That's the main goal, okay? So, for example, if I were to bring up this project and I create a new file here, .gitignore, okay? And I can say like, you know, .env or .venv, and I could say something like, you know, ignored file, right? If I create a file like ignored file, okay, so I have this ignored file here, all right? And then if I go to my terminal, sorry, this isn't a Git repository, so I need to do that real quick. If I do a git status, you'll see it doesn't see ignored file, right? It only shows the other two. And that is because ignored file is listed in my .gitignore, okay? So that's really useful for keeping files out of Git. And it's very important for secret files, okay? Does that make sense so far? Great. All right, so also, if you need to, there's this website, gitignore.io. It is very useful for generating Git Ignore files. So you can say, hey, I have a Python project and I'm using, you know, I don't know, let's say I'm using Python and Ruby. You can create, and it just generates a Git Ignore for you, and you can just copy and paste that. Really nice, right? So that's actually what I'm going to do. is I'm just going to generate a Python file here. Create. Oh, come on. Yes. Yes, I am. Thank you. Great. And I'm just going to copy this. And I'm going to dump it in my Git Ignore. Done. No more thought required. Okay. All good? Great. So now back to the presentation. All right. Licensing. This is super important. Basically, this is your legal protection. Okay. Why do you need legal protection? Because if someone uses your code and they break something with it, or worse, they break someone else's stuff using your code, you might get sued. You don't want that. So by including a license, you can basically say, hey, by using this code, I am not responsible for anything you do using my code. Okay? I made the code, but you're the one responsible for using it. Okay? It's basically a release from liability. Okay? That is a very, very important part. And therefore, you should include a license with every single thing you put in GitHub. Okay? Additionally, you can use a license to say how you are releasing this code, right? Because if you're putting it on GitHub publicly, it is open source. Anyone can view your code that you have written. Okay? But then how is it open source? Can they use it to start a business using your code? Or can they only do it for other open source projects, right? Licenses can be used for this stuff, okay? There is the open source initiative, which has a list of different licenses. You can just search for that. You can go through the different licenses there. CodeSeoul, we use the MIT license because we don't care. You can just use our stuff freely. As long as we're not liable for what you do with our stuff, you can use our stuff freely and that's it. So we use the MIT license, which says you can basically use the code for any purpose, commercial, non-commercial, whatever, okay? But definitely include a license because it legally protects you from liability. Good? So is a license important? Great, okay. So I'm just gonna pop over to the open source initiative here and I'm going to go to licenses. I'm gonna search for the MIT license and I'm gonna grab it here. I'm gonna copy this. Go back to my repository, make a new file, all caps license, paste it in here, change the copyright year to 2025. Holy crap, we're in 2025 now, guys. And copyright is CodeSeoul. Cool, that's it. Okay, so everyone do this for your project. It doesn't have to be the MIT license. Take some time to go through the licenses, okay? Find one that works for you, okay? There's a whole bunch of different ones. You can filter by the most popular ones, and there's all sorts of articles online about different licenses. I am rapidly running out of time, so we're gonna go faster. All right, so crap. So this is the pyproject.toml, okay? This is your project configuration file. Now, I'm not gonna go through setting this up entirely, okay? What we're gonna do is we're just gonna copy and paste a bunch of stuff. But the important parts are this includes info about your project, okay? In case you end up publishing it on the Python package repository. It also tells Python how to build your product or your software. And it allows you to specify, hey, I depend on this other software that you need to go download for my software to work. And it allows you to configure your tools. So, sorry, I'm just trying to get my notes here. And then it also has a bunch of tool configurations. So let's say you're using like linters and all that kind of stuff, which we'll cover in a second. You can configure them mostly in this file. And then there are some helper scripts. Okay, so there is a guide. If you just search for writing PyProject toml, okay, you can find this guide. You can basically just scroll to the bottom and copy this. So that's what we're going to do. We're just going to copy this. Okay, so again, search for writing pyproject.toml, copy that, and just make a new file, pyproject.toml. I'm going to copy that, paste it. Let me clean this up here a little bit. And none of this is correct, but we're going to go with it for now. Yeah, so I'm just going to use that for now. Okay, we'll clean it up later. So the main part, the most important part of this are the dependencies. So basically, where is it? There we go. What other software your software needs to use in order to run, okay? Because that's super important, and your project's not going to work without that. And then here's the next big one. For those of who would say they're very new to Python? Okay, only a couple people. So I'll go through this a little bit faster then. So first off, virtual environments are very important in Python. But what is an environment? An environment is mostly the system, right? And like this thing here, okay? Mostly the system and the configurations on that system, wherever your code is running, okay? So this includes things like Python version, what dependencies are installed, any files on your computer, any folders, this kind of stuff, okay? If the environment is not set up correctly, for example, wrong version of Python, or maybe Python is not installed at all, right? Your project won't run, okay? So it's very important that the environment is set up properly. However, what if you work on more than one project, right? They're going to need different dependencies. They're going to need different systems, maybe even different Python versions. So how do you run multiple environments on one computer? You're not going to get a new computer for each Python project you're doing, right? So instead, what we do is we create virtual environments, okay? Now, virtual environments, they make Python think it's a whole new system, a whole new Python installation. Okay, that's why they're called virtual. And they're very easy to set up. You could have different virtual environments using different versions of Python. You can have them with different dependencies. And this is very important because let's say you need library A in one project, but you also need library A in another project. But in this first project, you need library A version 2. In this other project, you need library A version 3. How do you do that? You use virtual environments. If each project has its own virtual environment, you can install library A version 2 into this environment. You can install library A version 3 into this environment, and they're completely separate, and everything is okay. Okay, so virtual environments are very important. They're the first thing you should do when setting up a project. And you do that using the venv module. So let's go ahead and do that. Let's go back to our project here. And down at the bottom, I'm just going to say Python -m. Whoa, M is in module. Okay. And then env. Okay. That's a virtual environment module. All right. And then because I'm using VS Code, VS Code by default uses the folder .venv to store the virtual environment. Basically, when you run the virtual environment module, you have to tell it what folder to set up the environment in. Okay. Usually I use .venv because I usually use Visual Studio Code, and that's the default. So if you do that, you'll notice it creates this new folder here. This is automatic. This was in my Git Ignore, so this is why it's blank. And it takes a few moments, but now it's set up. And if you actually look inside, you can see, where is it? You can see Python's actually installed here. Okay, so this is the virtual environment. But we're not done yet. We set up the virtual environment, but we're not using it yet. Okay, in order to use it, you must do source and then .venv. Go away, please. And then bin activate. Okay, this is a script that basically puts you into that environment, and then you start using that environment. Okay, so now you'll see here. You see how this got added to the beginning of my prompt? That's telling me I'm using this Python virtual environment. Okay, so if you see this, you're good. If you don't see this, you need to activate your virtual environment. Is all good? Everyone's got that? Cool, cool? All right. Now, rapidly running out of time. So dependencies, right? I mentioned earlier, you can have different versions of dependencies. You need to keep them separated, but you can also have constraints, right? I said it earlier, maybe this project requires library A version 2. How do you do that? You can set constraints. So you can say that, hey, I need a library greater than this version. or less than that version, or these kinds of things. Most often you'll see a kind of tilde equals, basically something that looks like this. That is very common. That means basically version 2 in this case, which is not valid, but whatever. Some version that is compatible with version 2. Okay, so it might go like one version up, one version below. Honestly, I don't remember exactly. I just use this and it works well enough. But yeah, that's how you can kind of make sure that you're using the correct version of a dependency. Now, why do you want to lock the version of a dependency? Because if they make a change and then you go install the dependency on a new computer, let's say you get a new laptop, and then you download your project, you install your dependencies, but then you install a newer version than what you had built your project with, now your project might be broken. Maybe the dependency changed its code so that it doesn't work the way you expect it to anymore. And now you've broken all your stuff because you did not lock your version. Okay, so make sure to lock your version, at least for your required dependencies. All right, does that make sense? Yes. Yeah, so as I recall, it means some version that is approximately compatible with this version. I forget how they calculate it. I think it's like 1 or 2 minor versions up or down. Honestly, I don't 100% remember. I recommend looking it up. It's looser than just saying straight equals, which is like exactly only this version. But it's not quite as smart as using full semantic versioning. But I recommend looking that one up. I'm sorry, I don't have an answer for you off the top of my head because I had limited time to prepare. Other questions? Great, I gotta hurry up. We are running out of time. Right. So now you're in your virtual environment, you have your dependencies set up. So what next? So what we can now, we want to actually install our dependencies and get our project ready to run. So we can do pip, which is the Python package installer, okay, PIP. If we say install, all right. And now, also, I'm sorry this is so small, but there's not a whole lot I can do about it. We want to do -E to install the project in editable mode, okay? This means that we don't have to do a whole bunch of crazy stuff in order to run our project, okay? So we can do pip install E and then dot for the current directory. We want to install the current project, and that will download and install all the dependencies, okay? So first I make sure that I'm in my virtual environment, then I can install, and you see it's going to read the file, it's going to check the dependencies, and everything broke. Yeah, this is what happens when you just copy and paste stuff without checking it. You can go away, doesn't matter. Sorry guys, you'll have to remove that readme.rst if you copied it like I did. Come on, nope. Oh man, why are you, okay, right, that's not a valid version. Oops, 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 oops. It's gonna work eventually, I promise. Nope. Right, we're getting rid of that. Let's just get rid of all these because I know these are not gonna work. And where's that foo? Oh, come on. What? Oh, I already got it. Great. All right, anyway, you do pip install E and then dot to set up the current thing. It should install all the dependencies, and I can't get it to work right now, but trust me, it does work. Where is this? Oh no, that's an example. Because I don't actually, right. This is gonna work if you don't actually have Python files. So I'm just gonna create a blank module source, and then my project and new file. Okay, now we have what should be a valid Python module, and now it should work. Okay, anyway, you guys get the idea. I'm sorry I can't demonstrate right now, but we're pretty much out of time. Yeah, I'll troubleshoot it later. But anyway, you can reference our versions online, which I'll share later. So then, once you have everything installed, you've probably seen code look like this. right? This is terrible. But you know, we have systems that can automatically format code and also automatically catch errors for you. So these days, very popular, or these tools are called linters. Linters catch kind of obvious errors, and then formatters for making sure the code is formatted in a very easy to read manner. All right. And you can also write arbitrary rules to enforce various practices. So there's a bunch of different tools to do this in the Python community, but everything seems to be converging to a single tool called Rough. It seems to be getting very popular very quickly. So we're actually going to use this for the projects that we set up. And you can use Rough to basically auto-format this kind of stuff. I know this isn't Python code, but pretend it is. And it will automatically find errors for you. It will automatically format your code, all this kind of stuff when you run it. Okay? And we're going to cover how to set that up in a minute. I want to cover real quick. I'm going to go a couple minutes over time, guys. I'm sorry. Only 2 or 3 minutes, I promise. So cool. We have this way to format our code and automatically catch errors, but how do we actually use this? There's something called Git Hooks. Okay? So earlier you learned about the Git pipeline, right? You change a file, you stage it by doing git add, and then you commit, and then you push it, right? So Git hooks are basically ways to, at every step of this Git process, right, you have the opportunity to trigger something, okay? So at some step in Git, it can run a script. This is very useful for kind of pre-review. You'll find that many systems use this pre-commit hook to run a linter and a formatter to make sure your code is in a good state before you actually commit it, before you actually put it into the history. And this is a very common and good practice to make sure that clean, usable code is the only code that gets committed, okay? So it's very important to make use of these. The problem is Git hooks are not included in your source code by default. So how do you share Git hooks between everyone? If like I have a Git hook set up on mine, but I want you to have a Git hook set up on yours, how do I do that if that Git hook's not actually in the repository? Well, we have a tool for that. There is a tool called PreCommit. Okay, it is very, very popular. It is written in Python, but it can work for any language. And basically, it is a way to configure Git hooks as part of your source code. Okay, so you can say, hey, I have this hook with these configurations, and I'm just going to commit this file to my project, and then everything can just work. Okay, so let me just grab an example here real quick, and then we'll be done. I'm pretty sure this is the last. Yeah, this is the last one. So give me just a second here. So I can make a where'd it go? I can make some file. No, I don't want to make it there. I want to make it out of the root. Ugh. Oh, it is at the root. I don't know, whatever. Dot pre-commit config dot YAML. Oh wait, this is old. Crap, I gotta crap. Oh, lame. Okay. Anyway. And then you can basically dump this in here. And this will say, hey, there's a whole bunch of default pre-commit hooks. So I want something to check that my Python actually parses, to check if there's like a case conflict, like if I'm using an uppercase when I should be using a lowercase. Check if any YAML files are in the correct format. Make sure that I have an empty new line at the end of the file, remove any trailing white space, all these things to kind of clean up your code. And you can just define all these configurations and then just save it to this file, commit this file, and you're good, okay? Now we're gonna set up kind of all these configurations for you guys to use as a reference a little bit later today when you're setting up your first server. And you can basically either just clone the stuff, or rather fork it and then clone it, or just copy and paste into your own project so you can have all these configurations. But once you have this set up, basically whenever you try to commit, it'll automatically run all this stuff. So again, you can make sure that your code is clean before it actually gets committed to history. Does that make sense? Great. So, any final questions before we break for lunch? Yes.
So the hook edit the code without us seeing it, right? We don't see the changes. Does it have the changes?
So let's go ahead and so let's say here's a project that we have here. Let's say I do something like random broken code, okay? And let's say I try to commit this. What'll happen is pre-commit actually runs when I try to commit, and it says, hey, this is not valid Python. Okay. Now, that is not an automatic thing of Git Hooks. Okay. That's just that pre-commit has been written to do this. Okay. So all Git does is it says, hey, I'm configured to run this hook. I'm going to run this hook. That is all. But usually good Git hooks will have some kind of output to kind of tell you what's going on. Does that make sense and answer your question?
Yeah. Also, I can put it in the IDE too, right? The linters.
Yeah.
Just to see.
Yeah. So usually linters will pick up on your IDE configurations. Or sorry, normally IDEs will pick up on your linter configurations. Yeah.
Sorry, can we define our own custom actions for hooks?
Yes, yes, you can. The hooks, they're really just running a script. So if you can write a script, you can write a hook. All right, anything else? Yes.
I actually, you say that the pre-commit uses the hook that is pre-commit, right? Like the different stages of the hooks to show that there is the pre-commit hook. Right?
Yes.
And then the pre-commit if doesn't only triggers only the pre-commit hook, or can I use the post-commit or something else?
So the pre-commit tool is designed to only do pre-commit hooks. Now, if you want to define other hooks, you can totally do that. But the pre-commit tool is only designed to work for pre-commit, as far as I'm aware. But you can always write your own hooks and then write systems to like automatically set up those hooks, but that's something you have to do yourself. Does that answer your question? Great. Any other questions? Yeah.
We have to create another file for post-commit. I mean, I want to post-commit action.
Yes, you would need to write a separate script to actually be the commit hook. And then you would have to, you'd basically have to go either symlink it or copy it into the right location in the Git configurations. I'm not going to cover the Git configurations right now, but if you look up a Git Hooks tutorial, they'll tell you where to put the file for it to be triggered. But yeah, does that answer your question? Yeah, so I'll share the presentation in Discord shortly, and then I'm going to have kind of a blank project slate to share with you guys in the running your first server session. Sound good? Great. All right. Yes.
Initially, say that you are using the rough.
Yes.
That, I saw that you are not using the rough. You are using sign over.
Yes.
Action has the rough.
Yeah, so I actually tried to pull the updates to use rough, but I have a conflict and I'm like, I'm not going to fix the conflict right now, but yeah, the version that I'll share with you guys will use rough. Yeah. Yes.
How strict you want your linters to be? Some of them are too strict. Just pushing everything. Some of them are more relaxed.
Yeah, so that was one of the big reasons that there were so many different linters in the Python community. And like there was like one really, really strong one that people like, yeah, anyway, you can configure them. They have different configuration levels where you can turn on and off different checks. And this is true of most linters, including rough. So you can configure it to be like tighter or looser, however you like. Does that answer your question? Great. Any other questions before we end? Great. All right, friends. We'll go grab some lunch. Try to be back here by about 1. We'll just kind of have open discussion and answer any questions you guys have. And beyond that, find something delicious. All right. Bye-bye.